How fast is the height of the water increasing as the water is pumped into the pool at 5 feet cubed per second at the heights of 2 feet, 5 feet, 7 feet, and 10 feet? This is a related rates problem. So, to solve it, what do you use? We use calculus to solve it. So, I'm going to start out with 2 feet. So here's my picture of what the pool is. So, I'm going to start out with 2 feet. So here's my picture of what the pool is. The top rectangle is where the pool is flat and even. And then the bottom triangle is where the pool starts to get deeper. Because we're doing 2 feet, if you see on the triangle, it goes only up to 8 feet. Because we're doing 2 feet, 2 feet will lie in the triangle section of the pool. Therefore, we only need to worry about the volume of the triangle. So, the volume of a triangle is 1/2 times width, length, and height. To solve for this, we must use a ratio, like this one. Length over height equals 75 over 8, because the length of the pool is 75 feet and the height is 8 feet. Therefore, L equals 75 over 8H. So, we come back over here and we plug in L, which is 75 over 8H, to this equation right here. Once we do that, we can combine like terms and get the next line that we have here. We can then take the derivative of that, which would be dv dt equals 75 over 16w times 2h dh dt. We used the product rule here, and we found that since dw dt equals 0, because the width never changes, we learned that that part cancels out. We know that dv dt equals 5 because that is what the rate of the pumping water into the pool is. So, you multiply all of those numbers and you get that dh dt equals 0.00593 feet per second. Now, h equals 5. To do this problem, you must also use a ratio, because it is when h equals 5, you are still in the triangle section of the pool. Therefore, you must use a ratio. L equals 75 8H. You must plug in that for L here. You take the derivative. You must also use the product rule. You know that dw dt will be 0 because the width never changes. dv dt equals 5 because that is the rate of which the water is being pumped into the pool. W is 45 because the width is always 45. And 5 is because that is the height, at the height that we're trying to find, how fast the water is increasing. So, we should get a smaller answer because at a higher height, the water will be increasing at a less quick rate. To solve for when h equals 7, you must also use a ratio, because this part, when h equals 7, is also in the triangle part. So you must use the ratio L equals 75 over 8H to substitute in for L. V equals 1/2 WLH. V equals 75 over 16 H squared W. You have to use the product rule to find the derivative of this. So dV dt equals 75 over 16 H squared dW dt plus W 75 over 16 plus 2 or times 2H dH dt. dW dt is once again 0 because the width does not change in this problem. So that whole section becomes 0. Then we have dV dt equals W 75 over 8 H dH dt. Then you can plug in the numbers and you get 5 equals 45 times 7 times 75 divided by 8 dH dt. And then you solve for dH dt, which is 0.001693 feet per second. When H equals 10 feet, it is in the section of the pool where there is a rectangular prism. Therefore, you do not need a ratio to solve this problem. Also, L and W are constants and do not change, so they do not need to be in a ratio. Therefore, we have the equation V equals LWH, length times width times height. dV dt equals L, length times width, dH dt. dV dt equals 5, L equals 75, W equals 45, and then we need to solve for dH dt. dH dt equals 0.00148 feet per second. Something to tell underclassmen about this problem. You must think in layers, like perimeter, area, volume goes in one direction, and antiderivatives and derivatives. It really helps if you think in different layers like this.